Okay, population or parameter and statistic. Population parameter. Actually, let me restart and say this. Parameter is a characteristic of the population. Statistic is a characteristic of the sample. So they could be anything. It could be averages, could be hair color, could be anything. If it describes a population, it's a parameter. If it describes a sample, it's called a statistic. Okay, and we give them different names. Like for mean, we use mu for parameter, or for population, we use x bar for statistic, for example. Okay, for 22, how well materials conduct heat matters when designing houses. As a test on new measurement processes, 10 measurements are made on pieces of glass known to have conductivity 1. The average of 10 measurements is 1.09. Is each of the bold-faced numbers a parameter or statistic? Well, let's see. I took 10 measurements, which is a sample, so that's 1.09. So this is a statistic, because it's just a sample. Now, the whole population, it says the known conductivity is 1. That's the population measurement of my glass, in terms of the conductivity. So that would be a parameter, because that's talking about the bigger picture, the parent group where we took the measurements from. That's the population. Okay, same thing in 23. We've got this experiment with these, let's see, children in small and regular, they were assigned smaller regular classes during their first 4 years of school. When they reached high school, 40.2% of blacks from small classes took the SAT or ACT, and 31 from regular classes took it. Okay, so both of these were samples, so both are statistics. And we know they're samples because it's just from an experiment. They were kids taken out and put in this experiment. It's not the whole population. Okay. And 24, roulette. Okay, so let's see, you bet on red, and you have it 18 out of 38. So if you bet $1, you win 2. Which means you win your dollar. You lose your $1, but then you win $1 back. And if you bet on red or black, that's what you get. Green is the banks, so you lose that. So you got 18 red, 18 black. I'm assuming you read it. So I did a bad job of explaining it. Total, so there's 2 green. Okay. The probability of winning $2 is 18 out of 38, because that's red or black, right? If you bet on red, it's 18 out of 38. Black, it's 18 out of 38. Okay. And the mean payoff is going to be 94.7 cents. Slightly less than $1. And again, we're going to learn how to calculate that coming up in the next chapter or 2. But for right now, this is what the payoff the casino pays for. My kids are playing with the dog now. The mean payoff from the casino is going to be 94.7 cents. That's the average payoff from the casino. 94.7. Now I know that because if this was if they had a 50-50 chance of winning, then it would be $1, because half the time they would lose the $1, half the time that you would win $1 when you'd win, and it'd be 50-50, and then the casino wouldn't make any money. Well, since the average payoff from the casino is 94.70, oops, get that off there. I don't know why it's doing that. Go there, but there we go. Because this is less than $1, and you're paying $1 for every game, in the long run, they are making on this bet, 5.3 cents per bet in the long run. Okay, because in the long run, you're going to win 18 out of 38% of the time, which is, I believe, about 47% of the time. You're going to win. So you're going to lose 53% of the time. You're going to lose more. Okay? And so the bank's going to win in the long run, or the casino's going to win in the long run. Okay? There you go.